Assalamu alaikum. Today we have important discussions related to the theory of production, which we started in my previous lecture. And I think this is my fifth or fourth lecture of the series of the production. And today the topic of discussion is separable production functions. First of all, what is the meaning of the separable production function? It is very important because whenever we talk about the concept of the horizontal and vertical integration during the stage of production, what does it means by the vertical or the horizontal integration? Vertical integrations, horizontal integration means के same nature of the productions you incorporate with each other. Let's say Gul Ahmad Textile and has horizontal integration with Navina Textile. Okay, so it means the same nature of the productions, they are integrated with each other due to any reasons, or they have a joint ventures to increase their production or to minimize their level of cost. Clear? To achieve economies of scale. So that's why sometimes different nature of the companies or the productions, they merge with each other in case of the horizontal integrations. And as far as the vertical integration is concerned, when we talk about the vertical integration means General Motors, now it is going to manufacture the tires. Okay, and same kind General Motors is also going to manufacture the automobiles, so they are vertically integrated with each other because both are the different nature of the productions and they have joined with each other. Clear? So what does it means ke, let's say ke if you calculate the marginal rate of technical substitutions between General Tires motor or General Motors. Okay, so General Motors productions does not affect the marginal rate of technical substitutions of General Motors will not affect the General Tires. Clear? So it means that both production functions of each production units are separable. They do not affect with each other. So this kind of the concept we assume in case of the production theory. We have strong assumptions that the production function should be separable with respect to the inputs. Okay, so how you can define theoretically what will be the separable production function? So for example, in general, the MRTS between labor and capital at input X depends on the level of each input if we divide into different type of groups, and these group exclusive sets or subset, that is S greater than 1, one, two, three, n. Yes. S greater than 1. Yeah. So, sorry. S greater than equal to 1, then the MRTS between two inputs, for example, I and J, does not affect with change in input K. The production function is weakly separable. How you can write it? Dawa Fxi upon F x dawa xk. All I j belongs to ns or s and k does not belongs to ns. What does it means? The change in inputs I and j with respect to change in another input k, and that k is not the part of this subset or this group. So both production function are weakly separable in nature. Why we assume this kind of the property in case of the production functions? Because we assume otherwise it is not possible of the concept of the horizontal and the vertical integration or the large scale production or the multi nature of productions. For example, Nestle, clear? Nestle production function is separable, let's say in case of the milk or in case of the Nestle mineral water, right? The Nestle is going to produce the both nature of the production, mineral water, and mineral water marginal rate of technical substitution between labor and capital does not affect the marginal rate of technical substitutions with the production of milk and something else. Clear? So both are operating by Nestle, Pakistan, but they are separable. So we can assume that the Nestle has a property of the separable production function. Clear? You may have different type of other example, right? So that's why we have to assume the production functions by nature is separable. Otherwise, this nature of production is not possible. There will be a no kind of the concept of the multi-plant monopolist or the multi-plant monopolistic competitive market. Clear? So any production stage may be a single production or the multi-plant productions. Right? So if you don't have the separable production, so multi-plant production is not possible. Or why you assume why the Nestle is doing? Ultimately to achieve economies of scale by producing the different nature of the productions. ऐसे ही है ना, otherwise अगर वो नहीं produce करेगा तो it is not possible. Sometime may be possible in case of the mineral water they have a loss or they have low market profits as compared to the Aquafina by producing the Nestle mineral water. So by producing other nature of the production, milk and medicine and something else, they may have a profit as compared to the Abbott and other companies. So that's why normally at the large scale production, firms or the companies or the productions, they opt a multitasking production task or the which is called the multi-plant monopolist or the monopolistic competitive market. Clear? तो आपके सामने एग्जाम्पल है, कोई भी नॉर्मली आप देखो सिमिलरली इकरा it is going to operate by Lakhani group, right? Or they have a textile mill as well. Clear? Similarly, they are going to provide the education services. So this is best example of the education services. MRTS will not affect by the MRTS of other group, which is called the textile, Lakhani textile. Clear? So it means that there is the property of the separable production functions in case of the Lakhani production. Okay, so now similarly the production strategy is separable if groups outside. Okay, so this is called separable production function. Now we are moving towards the elasticity of scale and elasticity of substitution. This is another kind of the important topic in case of the production strategy. And when we talk about the elasticity of scale and elasticity of substitution, so we discuss briefly about the concept of homothetic production function. And what we concluded briefly, the case of homothetic production function कि homothetic production function may have increasing returns to scale, it may have constant return to scale or decreasing return to scale. ठीक है, all the possibilities are possible in case of production, but these possibilities are not possible in case of utility function. So that's why we don't have any kind of the assumptions of homothetic utility function. Clear? We have a assumption of homothetic production function. So homotheticity is discussed with reference of the productions, not with reference of the consumer theory. Clear? So what does it means? How you will calculate the concept of increasing returns to scale or the increasing returns to scale, decreasing returns to scale? We have the concept of the elasticity of scale. That elasticity of scale will decide ke what nature of returns you have during a production. Clear? So today we will discuss the elasticity of scale. Similarly, the elasticity of substitutions. As far as elasticity of substitution is concerned, elasticity of substitutions means that we are discussing about the nature of curvature of the isocon. What does it mean by the nature of the curvature of the isocon? I pointed out you कि now normally we assume that generally there is constant elasticity substitution production function. Okay, अच्छा, constant elasticity substitution functions we have discussion in theory of consumer or the consumer theory, that is called the CES, constant elasticity substitution function. And that concept of the constant elasticity substitution functions we discuss in case of production theory. On the basis of the CES production function, we derive a relation of the Cobb-Douglas production function, nature of the production function, linear production function, and the Leontief or complement production function. Clear? So now today we will calculate the elasticity of substitution with respect to the Leontief production functions, Cobb-Douglas production functions, and the CES production function. Clear? So first of all, now move towards the elasticity of substitution. Then we will go to discuss the elasticity of scale. Okay, elasticity of substitution. Normally represented by sigma ij or sigma L K. Elasticity of substitution. Okay. First of all, one important assumptions related to the elasticity of substitution. What about that? Elasticity of substitution is whenever you have a quasi-concave production function, and we have discussed that why we assume the quasi-concave production function. Quasi-concave production function is a weak notation for optimization. Clear? And when we talk about the concave production functions, so it is strong assumptions that you don't have constant returns to scale, decreasing returns to scale, or increasing returns to scale. That's why normally to relax our strong assumptions, because all the possibilities are here and we have already assumed that the production function is homothetic. So when we have assumption of the homothetic production functions, to all the possibilities are here: increasing returns to scale, decreasing returns to scale, and the constant returns to scale in case of the homothetic production function. So that's why we have to assume that the production function is strictly quasi-concave. So now the one strong assumption is that when the production function elasticity of substitution assumption, you assume that production function is quasi-concave implies that elasticity of substitutions will be greater than zero. Okay, elasticity of substitution will be greater than zero. It means labor labor capital ratio labor and capital direction. We will discuss later. Now, what is the formula of the elasticity of substitution? The proportionate proportionate change in capital labor, that is ratio, relative to change in proportionate change in marginal rate of technical substitution between labor and capital, between labor and capital. ij x naught d ln mrts ij x is a function of r divided by r. x j x बता रहा हूं x naught. Like how you will calculate the elasticity of substitution. For example, it is input I, this one is input j. This is x, isocond. Okay, this is r, for example, x j over xi. Am I right? m r बता रहा हूं. It is your isocond, right? And the vertical line from origin to that curvature represent the ratio between two inputs. Similarly, this is another line which is going to touch this isocond at this point. It is another ratio of labor and capital. Clear? So ultimately, let's say it is x1 and this is kind of xij. Yeah, just a minute. Xij over xi1. Clear? The proportionate change in labor and capital and labor ratio. Percentage change in x j over xi. Right? The change in this labor and capital ratio. Divided by, this is MRTS. MRTSIJ1. And now this is MRTS IJ, for example, 2. Sorry, ये 1 and 2. So proportionate or the percentage change in MRTS between IJ. This is basically elasticity of substitution. Clear? This is basically elasticity of substitution. Ab now, labor and capital substitute with each other. ऐसे ही है. This labor and capital ratio and this labor and capital ratio will be different, right? Depends on the change in MRTS. What the marginal rate of technical substitutions is going to decline when we move downward along this curvature. The marginal rate of technical substitutions, it is increasing when we move upward towards that curvature. Right? अच्छा. अब now, for example, अगर मैं plot this kind of curvature, it is also convex to the origin. Look at this one. The marginal rate of technical substitutions and compared to this marginal rate of technical substitution. The change in marginal rate of technical substitution will be larger here. इसका slope steep है, इसका flat है, तो marginal rate of technical substitution, the change in marginal rate of technical substitution along this curvature will be larger as compared to this one. ऐसे ही है. अब जितना इसको एक्सपेंड करता जाऊंगा, फ्लैट करता जाऊंगा, तो चेंज इन मार्जिनल रेट ऑफ सब्स्टिट्यूशन विल डिमिनिश और डिक्लाइन एंड वन टाइम इट बिकम अ कांस्टेंट. क्या हो जाएगा जब ये कांस्टेंट हो जाएगा? इट मींस दिस मार्जिनल रेट ऑफ टेक्निकल सब्स्टिट्यूशन, द चेंज इन मार्जिनल रेट ऑफ टेक्निकल सब्स्टिट्यूशन विल बी जीरो व्हेन द MRTS is keep constant in case of the straight line isocond. अगर isocond straight line हो जाएगा तो this MRTS will be constant. Now MRTS change is increasing when it is on deep curvature curve as compared to this one. जितना ज्यादा ये sharp curvature होता जाएगा, deep होता जाएगा, the change in MRTS will increase, और जितना ये expand होता जाएगा towards the straight line, the change in MRTS becomes zero. ऐसे ही है, क्लियर बिल्कुल. और एक वक्त आएगा the change in MRTS is not possible. मैं इसको यूं करते करते यूं लेकर आ जाता हूं. The change in MRTS is not possible, so it means the curvature will decide the elasticity of substitutions between the labor, capital and labor. So that's why I write here the proportionate change in capital and labor with respect to the proportionate change in marginal rate of technical substitution. अब क्या किया हुआ है यहां पे? सिर्फ इसलिए बताया है. नाउ दिस इज सेम काइंड ऑफ डेफिनेशन इन द बुक मैस्कुलल. ही हैज रिटन द डेफिनेशन ऑफ इलास्टिसिटी ऑफ सब्स्टिट्यूशन इन रिवर्ट वे. तो कीप हियर इज माइनस. उसने यहां माइनस रखा हुआ है. जब मैं इस रेशियो को चेंज कर दूंगा तो क्या हो जाएगा? ये पॉजिटिव हो जाएगा. सेम काइंड ऑफ डेफिनेशन यू विल हैव हियर. Clear? But way of explanation of formula is different in different book. The concept of the same. Masculine ने इस तरह लिखा हुआ है. Normal books में रीस में ग्रेवाल एंड रीस एंड आपके पास वेरियन, यू हैव दिस फॉर्मेट ऑफ द MRTS, सॉरी, इलास्टिसिटी ऑफ सब्स्टिट्यूशन, बोथ आर सेम, दैट्स व्हाई कीप हियर द माइनस पावर, उसने रेशियो को चेंज कर दिया है। क्लियर? तो आगे इसको हम इस तरह डिफाइन कर सकते हैं। ओके, वेयर इज डस्टर? So now I can first of all write here some important point. When sigma ij is increasing, it is easier, it is easier to substitute substitutes labor and capital. When sigma ij is increasing, it is easier to substitute labor and capital. Clear? When sigma ij decreasing, it is difficult to substitute labor and capital. जितना कम होता जाएगा elasticity of substitutions, it is more difficult to substitute labor with capital. अब now here R is xij, the ratio of inputs at x naught, x naught is a vector of curvature along IQ. Similarly, d ln x j divided by xi upon d ln mrts I j, that is equals to ओके, रिवर्ट कर दूंगा तो नाउ यू विल हैव अ पॉजिटिव साइन. मैंने यहां माइनस साइन, आई कीप इट हेयर, तो इसको चेंज कर दूंगा तो यू विल हैव डी एल एन एक्स जे ओवर एक्स आई अपॉन डी एल एन एम आर टी एस, एब्सोल्यूट वैल्यू ऑफ एम आर टी एस. तो नाउ यू विल हैव द पॉजिटिव साइन. क्लियर? यही हो जाएगा, पॉजिटिव हो जाएगा. रेशियो को रिवर्ट कर दूंगा तो यू विल हैव द पॉजिटिव वैल्यू हियर. अब नाउ व्हाई आई एम गोइंग टू टेक द मॉडुलस वैल्यू हियर, बिकॉज ऑफ द to ignore the negative sign of MRTS. Why? I have to take the change between two values. यहां पे ln अप्लाई किया है तो पॉजिटिव किया है, एब्सोल्यूट वैल्यू आई एम गोइंग टू कंसीडर बिकॉज ऑफ दिस ln. क्लियर? अब नाउ दिस इज डी ln x j over xi upon d ln, this is MPL, marginal rate of marginal product of labor. क्लियर? यही होता है डिफरेंशिएट ऑफ प्रोडक्शन फंक्शन विद रिस्पेक्ट टू द लेबर, तो मार्जिनल प्रोडक्ट ऑफ लेबर एंड दिस वन इज द मार्जिनल प्रोडक्ट ऑफ कैपिटल. सो MPL divided by MPK, that is equal to the MRTS between two inputs I and J. Clear? Up now this one is going to equal the sigma IJ, that is equals to D X J over I upon D Clear? ln can be expanded in this way. Change in, look at this one, delta Q, percentage change in quantity. How you can write it? Delta Q over Q multiply by 100. ऐसे ही होता है. Clear? और in case of differentiation you have dq over q multiply by 100. यही होता है ना आपके पास. Clear? So now I can expand this one, dxj over xi divided by xj over xi. Similarly dmrts, that was mrts, I have already expanded in this way, mpl over mpk, to dmpl MPL over MPK, this is MPI, ऐसे ही है, and this one is MPJ. Clear? So MPI over MPJ divided by initial value of MPI over MPJ. यही होगा initial value of Q और change in Q. So same kind of the concept we applied here. Clear? अच्छा, अब now ये हो गया. नाउ रीअरेंज दिस फ्रैक्शन, तो इसको यूं लिख सकते हैं डी एक्स आई सॉरी एक्स जे ओवर एक्स आई अपॉन एक्स जे ओवर एक्स आई multiply by df xi upon df xj, सही है, डिवाइडेड बाय डी सही, divide will convert into the multiplication or fraction will revert. So this is your elasticity of substitution. Up now there are some curvature of isocon IQ. Yes. This one. Clear? I and J two inputs. Right? Okay. So for example, it is, you will have this value here, and now R is what? R is X J over Xi. So ratio of this value, this line, it is X J upon Xi, am I right? Again you will have Xj upon Xi, so proportionate change in these two values. And what about this one? It is MRTS. Whatever the value of MRTS is here, clear? MRTS between I and J. The same value of MRTS between I and J, both are equal to each other. So the change in MRTS is 0. Clear? So in this condition, the delta MRTS between I and J is equal to 0. Whatever the ratio of Xi and J, I know, for example, it is this one, X1, and this is Xj over Xi, for example 2. Clear? So Xj over Xi 2. What about this one? Numerator is decreases and denominator increases. ऐसा ही है. So this value will be greater than this one. So I can write this one, X J over Xi 1 will be greater than X J over Xi 2. But MRTS is constant. Clear? Ab now what happened? The MRTS is constant. So ultimately, in case of MRTS is constant, the change in MRTS is here. This is the change in MRTS. Now this value is represent the change in MRTSIJ. Am I right? Derivative yani change in MRTS. When I keep ln, so that is called the percentage change. Yani when I take d ln, so it represents the percentage change. When I have only d, so it means that it represents the change, not the percentage change. So there is a technical difference between d ln or d. Derivative represent change. When we multiply this derivative or we take the ln of that derivative, so it represent the percentage change. Clear? So इसीलिए जब econometrics के अंदर whenever you have a log of the function, ठीक है, क्या करते हो? Take the first difference of the equation to make it stationary, and then sometime you have to take a log or ln of that functions. So that function represent the percentage change. So technically you have to think about, हम तो सिर्फ results को अच्छा करने के लिए कर लेते हैं. Normally you should have a justification why you are going to take a first difference to make it stationary. First difference क्यों ले रहे हो और why you represent the ln. अब normally क्या होता है, one variable in your explanatory variable in the log form or another variable in your functions is absolute in the absolute value. So technically it is not acceptable function. आप एक की ग्रोथ ले रहे हो, एक की एब्सोल्यूट वैल्यू ले रहे हो, या तो उसकी भी ग्रोथ लो, उसको भी ln में कन्वर्ट करो, क्योंकि when you make a function in the log linear form, तो overall log you apply. आप ओवरऑल अप्लाई करते हो तो ऑल द वेरिएबल्स बिकम इन द ln फॉर्म और द log फॉर्म, आइदर इट इज द डिपेंडेंट वेरिएबल और इंडिपेंडेंट वेरिएबल, ऑल द एक्सप्लेनेटरी वेरिएबल. बट समटाइम वी टेक, हम क्या करते हैं, जीडीपी हमारा एब्सोल्यूट वैल्यू में सही नहीं आ रहा, वो हमने क्या किया, उसको रिजल्ट को सही करने के लिए वी मेक इट इन द लॉग, उसको लॉग में कन्वर्ट कर दिया, बाकी वैल्यूज को एब्सोल्यूट में ले लिया, तो फंक्शन को वो जस्टिफाई नहीं है. वो फंक्शन वो आपने अपने रिजल्ट्स को मैनिपुलेट करने के लिए, अच्छा करने के लिए आपने सब कर दिया. टेक्निकली इट इज नॉट एक्सेप्टेबल और थियोरेटिकली. क्लियर? तो ये इट इज डिफरेंस. तो अब नाउ व्हेन वी टॉक अबाउट दिस वन, तो इट रिप्रेजेंट द चेंज इन एमआरटीएस. यही हो गया ना, बिकॉज इट इज एमपीएल डिवाइडेड बाय एमपीके. क्लियर? ये हो गया आपके पास. तो इट इज द परसेंटेज चेंज इन एमआरटीएस. व्हाट अबाउट द परसेंटेज चेंज इन एमआरटीएस इज हियर 0. or the change in MRTS is 0 because you have the same values here, same values here if you have the straight line isocon. So what does it mean? So what happened when you keep the 0 values here? So what happened? Whatever the ratios, मुझे उससे कुछ कंसर्न नहीं है, इससे भी मुझे कोई कंसर्न नहीं है. I don't concern about this one, but that value becomes 0. So it means कि overall fractions become infinity. Clear? So what about the elasticity of substitution in case of straight line isocont is infinity. Clear? So the case of perfect substitute. Yes. इसको ना, ठीक है ना, तो वो 0 हो गया. ये वैल्यूज कुछ भी हो, मैं इसको 0 कह रहा हूं, ये 0 हो रहा है मेरा. ये वैल्यू मैंने कैलकुलेट नहीं करी, मुझे पता है कि नाउ दिस वैल्यू इज इंक्रीजेस. हम नीचे जा रहे हैं तो हमारी वैल्यूज क्या हो रही है, लेबर एंड कैपिटल रेशियो डिक्रीज कर रहा है. व्हेन वी मूव अपवर्ड अलोंग द साइज, तो लेबर एंड कैपिटल रेशियो इंक्रीजेस. तो यानी इट मींस द लेबर कैपिटल रेशियो may change along the case of perfect substitute. It is not constant. Clear? But MRTS is constant. We have concluded here. ठीक है? So labor capital ratio may change. So now XJ over XI may change along IQ in case of perfect substitutes, in case of perfect substitutes, but labor, but MRTS, labor and capital, sorry, change in MRTS, labor and capital, yeah, MRTS IJ is constant. So now elasticity of substitution is infinity. Clear? Elasticity of substitution is infinity. Ab now move forward in case of, for example, the case of Cobb-Douglas preferences. These are the linear preferences or the production function is linear. ठीक है, either it is the log linear or the linear. ठीक है, the case of perfect substitute, the production function is linear. Now, for example, you have the Cobb-Douglas preferences. अच्छा, वो कर रहे हैं, डिस्कस कर रहे हैं. यस, यस. So imperfect or Cobb Douglas. Clear? The elasticity of substitutions lies between 0 and 1. It will not be 0 or it will not be infinity. Why? Reason is that it always asymptotic towards x-axis and the y-axis. Never touches to the x and y-axis. Clear? So I can write it or expand this isocond in this way, whatever the curvature is here. Clear? That is called take to x asymptotic towards x and y axes. Never touches to x and y axis. So in this condition, the elasticity of substitutions never be equal to infinity. The case of the perfect substitute, if it touches to the x-axis, so what does it mean? You have substituted all the capital with labor. सही है, and vice versa is here. So when it never touches, approaches towards x and y axis, so it means you don't have the infinity value of sigma, or now substitution is here always, so you value of sigma never be equal to zero, वो कभी भी जीरो नहीं होगी. The case of Leontief preferences. Clear? So in case of the Leontief preferences, okay, clear? So what happened? It is another IQ. This is another IQ again. So 1, 2. So xij over xi 1 equal to xj over xi 2. Am I right? The ratio of both values will be equal to each other. The same value you will have here, the same value you will have here. So change in ratio is 0. So the change, or I can say that d xj upon xi is 0. So when you have 0, what happened? Whatever the value of MRTS at this point, we are not going to calculate this one. We know that the change in ratio values of capital and Rabo is 0. So that's why your sigma value ij is equal to 0 in case of Leontief preferences. वो आपके पास 0 हो जाएगा.
This is perfect complements, right?
Perfect complement.
Fixed ratio.
Yes. Perfect complement is not the right word, because perfect complement means कि this line has a degree of angle of 45-degree line. It is not necessary. Sometime you will have the capital intensive technology or the labor intensive technology, so the ratio, the angle of the line will different. Let's say देखो, नाउ द एंगल ऑफ दिस वन अज्यूम कर लेता हूं 30 डिग्री. फॉर एग्जाम्पल इट इज एंगल इज 45 डिग्री and this angle is greater than 45. For example it is, assume कर लेता हूँ 60 डिग्री. What happened? Labor capital ratio is keep constant, again is keep constant, but the proportionate change in labor and capital is different. Why? You imply more capital as compared to labor. Similarly, same labor and capital you imply in this case. Okay, now you imply the more capital is here. Clear? So this line represent the more labor intensive technology. Although there is no substitution between labor and capital, this technology is balanced. ठीक है, it is more capital intensive technology. You have more share of capital as compared to the labor. Ratio is same along the ray, but share of labor and capital is different. So you cannot say ideally they are perfect complements. That's why I'm saying. अच्छा, अब now move forward towards the derivations of okay. Suppose CES production function constant elasticity substitutions production function. What kind of the production functions? For example, y equal to x1 row, x2 row, and 1 over. It is already derived production functions. Clear? So there is no need to do the derivation of this, okay, how you derive this one. So just this is the derived form of the CES production functions, constant elasticity substitutions production function. ठीक है, रो represent the elasticity of substitution between x1 and x2. Okay. अब now, for example, we calculate the MRTS x1, x2. Again, this one is M x1, MPL, okay, or MX2. Am I right? Marginal rate of marginal product of labor divided by the marginal product of capital. MPL over MPK. अब now MPL over MPK. This value is equal to, इसको कर लेना, x2 over, मैं डायरेक्ट लिख रहा हूं, x2 over x1 divided by 1 minus rho. You will take the derivative of this one with respect to x1. एक बता देता हूं, do yourself and drive this form. Okay, this is simplified form of MRTS x2 upon x1 की power now 1 minus rho. So dawa y over dawa x, dawa x1. So now 1 minus rho into x1 row plus x2 row 1 over minus 1 over rho minus 1 multiply by the derivative of this one is rho into x1. So finally this is 1 minus rho
ये रॉ माइनस वन नहीं है ना रॉ एक्स वन
rho minus 1 किधर
ये आपकी ब्रैकेट का डेरिवेटिव ब्रैकेट का डेरिवेटिव
अच्छा ये अच्छा सॉरी थैंक यू ठीक ओके सो नाउ रो क्लियर तो अब हाँ कहाँ पे अच्छा मैंने रॉ रह गया रॉ यहाँ लिखा था ना ये रॉ ना ये रह गया उस वक्त लिखा था सॉरी राइट सो x1 रॉ माइनस 1 एंड रॉ को आगे लगा यहां कर लेते हैं ये रॉ x1 रॉ माइनस 1 क्लियर सिमिलरली डावा y over dawa x2 will be like this one raw x2 सही है तो raw minus 1 right और 1 minus raw bracket x1 raw plus x2 raw और 1 minus raw divided by raw clear x1 replaced by x2 बस simply and 1 minus rho is same x1 x2 is same तो ये भी सेम आपके पास हो जाएगा जी
वन माइनस रॉ के लिए ये बराबर रॉ नहीं पहली वाली
कहाँ पे बताओ
डावा y ओवर डावा x1 में
वन ओवर रॉ नीचे आया था 1 ओवर रॉ ये नीचे उतरेगा अच्छा हाँ सही है ये 1 ओवर रॉ नीचे आएगा ये कैंसिल हो जाएगा 1 ओवर रॉ और चेक कर लेना भाई 1 ओवर रॉ आ गया ये मेरे पास क्या आ जाएगा 1 ओवर रॉ इनटू रॉ सही है क्लियर अब देखो नाउ द रॉ कैंसिल आउट रॉ कैंसिल आउट क्या किया है देख लो फिर यहां पे लिख देता हूं इसको डिफरेंशिएट कर रहा हूं डावा यहां दोबारा कर रहा हूं डावा y ओवर डावा x1 क्लियर तो 1 ओवर रॉ नीचे आया राइट एंड नाउ x1 रॉ प्लस x2 रॉ क्लियर सब्ट्रैक्ट 1 माइनस रॉ तो डायरेक्टली आई एम गोइंग टू राइट 1 माइनस रो ओवर रॉ सही है क्लियर मल्टीप्लाई बाय अब नाउ दिस वन रॉ x1 रॉ माइनस 1 क्लियर तो दिस रॉ कैंसिल आउट तो फाइनली यू विल हैव x1 रॉ माइनस 1 क्लियर और दिस वन इज फिर भी चेक कर लेना x2 और 1 माइनस रो ओवर रॉ सही है तो नाउ इन केस ऑफ एमपी डावा y ओवर डावा x2 you will have x2 raw minus 1 again x1 raw plus x2 raw divided by 1 minus raw over raw. This is equal to mp x1, this is equal to mp x2. सही. अब now what happened? Take the ratio of this one, we need to drive this one. अब देखो all values will be cancel out, ये भी कैंसिल हो जाएगी, ये भी कैंसिल हो जाएगी. तो नाउ फाइनली अब देखो एम आर टी एस x1 over x2 equal to what? तो first of all this one x1 raw minus 1 and this value, clear? x2 raw minus 1, this value. तो क्या बच रहा है? raw minus 1 x1 over x2 raw minus 1. तो now x1 over x2 raw minus 1. Now change the fraction. So x2 over x1 1 minus raw. So you will have this value. Clear? Why you need to capital labor ratio, not the labor capital ratio as per the definition of elasticity of substitutions. The change in capital labor ratio, that's why we need to revert this fraction. Now it's become 1 minus rho. Now you will have the 1 minus rho MRTS between x1 and x2. ये मिटा दो. ओके, अब देखो सिग्मा x1 x2 d ln MRTS so d ln clear? That was the definitions. D ln x2 over x1 d ln MRTS between x1 and x2. It is the definition of elasticity of substitution. Now this value yes. So D ln MRTS labor and capital ratio, it is D ln x2 over x1 divided by तो constant. Clear? So finally you will have 1 over 1 minus rho, which is constant value. Clear? Depends on the value of rho. Clear? So it means कि that's why अब now this value of rho will decide, either you will have the case of perfect substitute. Clear? You have the case of Leontief preferences, or you will have a case of imperfect substitute between labor and capital. Clear? अब
मतलब आपने बोला linear linear
Leontief and Cobb Douglas. Cobb Douglas.
so raw form substitution value both that
The rate of substitutions between labor and capital. And this rate of substitutions will decide the value of the elasticity of substitution, either infinity, 0 or 1. वन का देखो, जब बिल्कुल स्मूथ आपका कर्वेचर होता है, जिसको आप परफेक्ट कर्वेचर कहते हो, कन्वेक्स टू द ओरिजिन, तो कॉब डगलस प्रोडक्शन फंक्शंस की इलास्टिसिटी ऑफ सब्स्टिट्यूशन जो होती है वो 1 होती है। क्लियर? और अगर इस तरह का होता है कि एक ये भी हो सकता है, ठीक, नाउ ये भी डेरिवेशंस करवाऊंगा तो बताऊंगा भी, इसलिए रुक गया था। एक ये भी हो सकता है, अब देखो, ऑल आर द कॉब डगलस प्रेफरेंसेस ना, these are the Cauchy linear preferences or not the perfect Cobb Douglas preferences. So this is ideal Cobb Douglas preferences. ठीक है, तो वो अभी हम डिस्कस करेंगे। इस वजह से अभी मैं रुक गया था, तो उसके हिसाब से देन वी विल डिसाइड द वैल्यू ऑफ सिग्मा विल बी 1 और लाइज बिटवीन 0 एंड इंफिनिटी। ठीक, उसमें ये बस इसकी वैल्यू रेंजेस में है। परफेक्ट आइडियल केस से 1 हो जाएगी, ऑल लाइज बिटवीन 0 एंड इंफिनिटी। बट द केस ऑफ परफेक्ट सब्स्टिट्यूट इंफिनिटी आपके पास हो गया। केस ऑफ द लियोनटिफ द सब्स्टिट्यूशंस विल बी 0, वो फिक्स है। क्लियर? तो आगे मूव करते हैं। मेरे पास ये था. Suppose that the technology is linear. Suppose technology is linear. Q is A plus BL. Okay. Q is a function of capital. BL. Okay. So if we change labor and capital by any scale that is t, which value is greater than 0. Clear? If the power of any value of t after factor out this one is greater than 1, so increasing return to scale is lies between this one decreasing returns to scale and equal to 1 CRS constant returns to scale. Clear? So linear technology also has increasing, decreasing and constant returns to scale. First of all, it is not necessary that you will have the linear technology. Case of the perfect substitute, so your returns to scale will be constant. Clear? So you may have the variable returns to scale, although you will have a linear technology, perfect substitute, where the elasticity of substitutions between labor and capital is infinity. अब तो similarly sigma labor and capital, it is percentage change in capital and labor ratio divided by percentage change in MRTS, labor and capital. Okay, so this percentage change is 0. So sigma labor and capital is infinity in case of perfect substitution or linear technology. Now, the case of fixed proportion.
Beyond this,
Yes, min A A B all. Okay, 0 0. Actually, one important thing is here. Let's say okay. After this point, for example, it is point A. After this point, marginal rate of substitution for labor is 0. हॉरिजॉन्टल लाइन हो रही है. Marginal rate of MPL या technical substitution for labor before this point is infinity, vertically sloped. Clear? So it means कि MRTS after point A becomes 0 for labor and it is infinity before point A for labor. Clear? So there are the two possibilities, right? Which we discuss. What happened, although the elasticity of substitution is equal to 0 between labor and capital both, but in case of labor only there are the two possibilities that after that point it's becomes 0 or after, before that point it becomes infinity. Clear? So just note down this one. Ab, the last case is Cobb-Douglas preferences or the Cobb-Douglas utility function. Clear? CES we have discussed. CES 1 upon 1 minus rho, it is constant value. Clear? So elasticity of substitution will be constant. Means what will be the constant? Either it will be infinity, it will be 1, or lies between 0 and infinity, or it will be 0. Clear? Yani it means if you will have a production function or you defined a production function, so your elasticity of substitution for that particular production function will be constant value. Cobb-Douglas. Okay. B. See, when we scale with t, so ta t की power b. So now you can factor out ta plus b, a a al b. So t into q. So now t is greater than 0, a plus b greater than 1, IRS increasing returns to scale. A plus B CRS. For example, F Q equal to A K A L B. So Dawa Q over Dawa K A A K A minus 1 L B, which is MPK. Dawa Q over Dawa L. This is B A K A L B minus 1 MPL. So MRTS labor and capital B A K A L B minus 1 A K A minus 1 L B. इसको रीअरेंज करो, इसको ऊपर ले जाता हूँ तो ये K ये हो जाएगा B अपॉन A इंटू K अपॉन L, राइट। ये ऊपर ले जाऊंगा माइनस पॉजिटिव हो जाएगा, ए कैंसिल हो जाएगा तो K की पावर नाउ द 1, तो सिमिलरली यू विल हैव द पावर ऑफ L इज 1
सबके नीचे आएगा,
है।
ये ऊपर जाएगा।
K ऊपर जाएगा तो ये पॉजिटिव हो जाएगा,
एलोवेट हो जाएगा।
तो K ओवर L हो जाएगा ना,
क्यों वाले
नहीं ना,
यस,
ये पॉजिटिव हो जाएगा और ये माइनस हो जाएगा तो माइनस ए कैंसिल आउट हो जाएगा, तो K की पावर 1, सिमिलरली L की पावर 1 भी सही है। ओके, अब नाउ so D ln M or TS labor and capital, that is equals to D ln A, sorry, B upon A clear into K upon L ln B over A plus ln K over L. Okay, so d ln k over l, replace with this one, d ln a, sorry, b over a plus d ln k over l. So log of any constant will be constant, and this change will be 0. So this value will be 0. When this value will be 0, so you can cancel out this one. So elasticity of substitution will be 1 in case of Cobb-Douglas preferences when A and B are equal to each other. Clear? When A and B are equal to each other, you will have a smooth convex curvature. So now we have discussed elasticity of substitution and separable production function. Clear? Okay, why we assume the assumption of the separable production function in case of the theory of the production? So we compare that concept with respect to the horizontal and the vertical integration. Okay, it means K marginal rate of technical substitutions for one stage of production or the one group of production between inputs does not affect the marginal rate of substitutions for another with another group or with another stage of production. Clear? We took the example of multi-plant monopolist. Took the example of the Nestle Pakistan. Ke Nestle is going to operate with multi-stage of production, mineral water, medicines, and so on. Clear? So their marginal rate of substitutions are independent with each other. That was the property of the separable production function which we discussed today. Similarly, after this, we started to discussion related to the concept of the elasticity of substitutions. Or first of all, we pointed out CES production function. In the case of the CES production functions, answer of the elasticity of substitution was 1 upon 1 minus sigma. Clear? So sigma was the elasticity of substitution between inputs, labor and capital. That value will decide either you will have the Cobb-Douglas, linear or Leontief. Clear? Finally, we discussed these three nature of production: Leontief, Cobb-Douglas and linear production functions. In all production function, we discussed that it is not necessary that your returns to scale will be constant. Returns to scale may be variable, because every production function, either it is linear, it is Cobb-Douglas or it is Leontief, it hold the property of homotheticity. Clear? Means that they all are the homothetic production function. When we assume that these all are the homothetic production functions, it means they have multiple kind of returns, increasing, decreasing, and the constant returns to scale. Clear? Then finally we calculated the elasticity of substitutions between these all kind of the production functions. ठीक है भाई, थैंक यू सो मच. अब मेरा इनफ हो गया है क्योंकि मेरी अभी आगे 2 और क्लासेस हैं. अल्लाह हाफिज़ भाई.